So this is a session which compresses the material in the patterns module almost completely into a 1-hour presentation. Now here's one of my favorite patterns of all time. This is sometimes called the meander pattern, or the meandros in the original Greek. And you'll see it on pottery and architecture in the ancient world, and all different kinds of manifestations over the last 2,000 or 3,000 years. But let's look at this pattern. Anybody take a stab at describing it? And there's a very interesting figure and ground thing going on here. G, G, G. Tell us about that. Do you mean the letter G? It's like the letter G repeating over and over again. Yep, I can see it. So you were saying that this letter G is around here. So that's looking, is that looking at the white letters, or is that looking at the, or excuse me, the white squares or the black squares? Because we sort of see here's a here. Then of course there's this other part of the white, which is the sort of upside down G that's interacting with that. Notice that the weight is not continuous. The white squares come down here and they go around, and then they're a bit like a bit like hands that are interlocked like this. So let's see if we can't kind of describe how that pattern is made. So we're going to follow the black squares out here, and we just sort of look down and we say we go down 1. So if we start with that first black square that's numbered 1, we go 1 forward, 2, 3, 4, 5, 6, 7, 8. And then we turn left and we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we turn left again and we go 1, 2, 3, 4, 5, 6. Left again, 1, 2, 3, 4, 5. Left again, 1, 2. Left again, 1, 2, 3. But now we switch directions. So now we're going to make a right-hand turn and go 2, and then another right-hand turn and a right-hand turn and a right-hand turn and a right-hand turn. But then here again we switched back to left, and so on. So we could write these out like this. We could say that if we're in square number 1 and we're pointed downward, we go forward for 9 squares, and then we make a left turn. And I'm writing these in kind of pseudocode here. So I've got F of 9 and then L with nothing inside. And so the L with nothing inside just implies I was pointed downward, and I'm just making that left-hand turn. So I'm still in square 9, and I turn and go this direction. And then I go forward so many, and then I turn left, and so on. So if we put these all together, and it looks like there's a typo up there. That should be an 8. But we can see the pattern repeating itself. So we're going to try something with turtle graphics. Anybody remember turtle graphics from like kindergarten? First year at university. Wow. Okay. Anyway, turtle graphics are great. They're a lot of fun. There's some wonderful software written using this idea, but originally it was used for teaching kids about computer science. The basic idea is that you've got a turtle, and the turtle carries a pen, and the pen can be either up or down, and the turtle can go forward a step, or it can turn to the right some degrees, turn to the left some degrees, and then all the normal repetition commands from computer code go with it. So right here we have a little demo which hopefully will run if I reset. And so this little turtle program, if we look over here, it says hide the turtle, set the color of the pen to blue, have a variable s equal to 100. So that means we're going to do 100 repetitions. We're going to draw a square of size s, and then we're going to turn 36 degrees to the right. We're going to subtract 10 from s and then do it again. So we're going to have 10 repetitions of this. First, we're going to draw a square of size 100. That's this square right here. And we turn 36 degrees and we draw a square that's size 90. And then we turn 36 degrees and so on. So turtle graphics is a cute way to draw spirograph, things like that. And this interface lets you do that here. So we could change this if we want and say, let's see, instead of 36 degrees, let's say 30 degrees. We'll reset it and then run the demo, and we get a slightly different pattern. Okay, so we're going to use turtle graphic spiral. So again, summary of what turtle graphics looks like. So this is my sort of version of the analysis we just did of that curve. I've basically created a function called R, which will turn us 90 degrees, a function called L, which will turn us minus 90 degrees, and then a function called spiral, which is that sequence of turns. So we turn right, we go forward 40, we turn left, forward 45, turn left, forward 30, and so on. And I'm just using the numbers 40, 45 here. This was originally what we did as forward 8, and I multiplied these things by 5 in order to scale it to the screen. So that's why these are not quite the same numbers we had in the original drawing. And then the demo, this is the part that will do the work. We reset it. We go to 200, minus 200, 0, so we're going to go to the left side of the canvas. Hide the turtle, color it blue, point downward, turn 90, and then we're going to draw 7 of these spirals and see how that comes out. So I'm going to just take this code right here and copy it, and then go over here and I'll get rid of what's there and paste this in. And let's see if we can get it to work. And so there we got. So this was a way of kind of continuing the logic we had when we were doing iteration, and saying, you know, one you go with iteration is to the generation of patterns. And one of the slides, oops, phone ringing, sorry. One of the slides we saw in one of the readings somewhere was of the Jacquard loom, which was an early mechanical loom, which basically used something like this as a way of generating patterns in cloth when we're weaving cloth with a loom. What we want to do, though, is go from the description of patterns for the sake of generating them to the description of patterns for the sake of finding them or recognizing them. So here's our first assignment. You've heard the saying, stare at a brick wall. So I want you to stare at a brick wall and find a pattern in this wall, which is a long red brick followed by a short purple brick, followed by another long red brick, and then a short purple brick, and then a long red and a short red. So just stare across there and see if you can't locate that somewhere on here. Middle row, 6th from the bottom. Let's see, 1, 2, 3. I go over here. 1, 2, 3, 4, 5, 6. So I'm assuming we're meaning this one here. One above, yes. Okay, that was what I thought. So let's see, 1, 2, 3, 4, 5, 6. So here we go. We have a long red, short purple, a long red, a short purple, and then a long red and a short red. There we go. So that's that's a time when we recognized and we found that pattern. So this process where we define a pattern and then we scan over some data saying is there a place where that data that pattern shows up is a really important operation. Let's look at if we try to do like a little flow chart on that. Right. So maybe we do is we start up in the upper left and we say if it's a red brick, that means if it's a long red, then I might be on my pattern. So I look at the next one and I say if that next one is a short purple, then maybe I'm on the pattern. And so if that's the case, then is the next one a long red? If it is, maybe I'm still there. And then I go short purple, okay, still there. And then I look at the next one, is it a long red? And then is the next one a short red? And if so, at that point, I have found it. But if any of these answers were no, then I'm going to drop to the end of this structure and I'm going to come out at the bottom. And notice we have this one exit, one entry. I'm going to come out the bottom and the answer is no, it wasn't found. And so we then say, okay, I'm going to have to loop around and start this process with the next brick. So that could be a rather tedious process. It's a lot of checking and decisions and keeping track of where we are and so on. Fortunately, there's going to be a standardized way of doing this that's going to at first look devilishly gobbledygooky. But once we get to play with it, what we'll see is that it actually is a really convenient standard way of describing patterns. So first thing I want to do is say, let's abbreviate what we're doing here the way it is in the middle of the page. So long red, short purple, long red, short purple, long red, short red. So LR, SP, LR, SP, LR, SP. But now I want to do is I want to sort of come up with some notation that's going to make it easier for me to write out that pattern. And so the first piece of the notation is going to be curly brackets with a number inside. And so what I'm going to have as a convention is if I write some pattern and then I have curly brackets, a number, and a curly brackets, what that's going to mean is that pattern repeated that many times. So if you look on the second line from the bottom, it says parenthesis LR space parenthesis space SP parenthesis. So the pattern is that. That's what is equivalent of this X. So long red, short purple, and then curly bracket to curly bracket says twice. So I want to say that's LRSP twice, and then LRSR. And any of you who've played music are familiar with a version of this, which is the repeat sign. So you'll have bars of music set off, and then it'll say repeat this much so many times, and then so on. So this is something we're used to. Any questions so far? Okay, so moving on. This is a piece of the transcript from the audio from our last session. And so this is when you get automatic transcripts made for video, this is what it looks like. The confidence lines, where it says note, confidence, blah, 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 that's the machine learning algorithm saying when I processed the audio from the timestamp 0032, or excuse me, 0000.24 to 0000.07.482. And I translate that as, okay, so two quick announcements first. So the algorithm says that it has 76% confidence that it got that right. And so this is a standard thing that machine learning algorithms, when they classify things, they say it could be different things, but I'm going to give you this as the answer because I've arrived at an estimate that says I'm more confident that that's what you said, that's the text of the audio, than I am of all the other things that that it might have said. So I have these things: note, confidence, blah blah blah, and then I have these long strings of digits. Um, it looks like there's 8 of them, dash 4 of them, dash 4 of them, and so on. Anybody notice what number system that's written in? It is hexadecimal, right? Now you can tell, right, because it's got letters and numbers, but we don't see any letters beyond the letter F, right? So what that is a long hexadecimal that's describing that particular piece of tape, that particular piece of audio. And then below that we have this timestamp, which is hours, minutes, seconds, and then thousands of seconds. And we have start, and then we have the arrow dash dash bracket for the arrow, and then we have the finishing time. So what I would like to do is I would like to edit this file and get rid of all this extraneous stuff so that all I have left is the transcript. So what I want to do is I want to take out all the times where it says note, duration, blah, blah, blah. And I want to say get rid of the note confidence parts, and I want to get rid of all these hexadecimal things. So I could go in and I could just highlight each of these and delete, but that's going to take forever. But then maybe I look and I go, wait a minute, look at all the confidences. They're all the same, right? 7622151, right? So maybe what I should do is just I'll highlight one of these lines and then do like a search and replace for that, and I'll get rid of all of those. Well, that's good, except it turns out that about line 40, the confidence changes and the numbers are different. And as I look through the file, it turns out that they're not all the same. And the rest of these hex codes are all different. The times are all different. So what I need is a method for searching for these strings which have some structural similarity, but which are going to have some difference in their details. Now, I'm going to introduce one more notation convention here, and that is going to be the notation that lets me specify a set of characters. And the notation will be square brackets, and then characters, and then a square bracket. And so square bracket ABC, square bracket, is going to mean an A, a B, or a C. And square bracket A-F is going to mean any character from A to F. And these things are going to be based on the ASCII encoding that we talked about in the numbers module. And so just for a refresher, here's ASCII 30 or hex 30, which is the character 0. And then you have character 9. Now you have uppercase A is hex 41. And then we have the alphabet of uppercase going through Z. Then we have a couple of other characters in here. And then at 61, we start with A lowercase. And A lowercase goes on to here. So we're going to describe character sets based on the contiguous groups that they're in. So if I wanted to describe any capital letter, I would say square bracket A, capital A, dash capital Z, uppercase Z, and then a square bracket. And that would say I'm talking about some uppercase letter. If I wanted to talk about all the lowercase letters, then I would say square bracket little a dash square dash Z, little z, square bracket. Okay, so that's our second notation that we're going to add to our mix here. Okay, now let's watch me play with this. Okay, so back to where we were. So the top box where it says find, I'm putting in search parameters there. And so what I put in is the actual text, note space confidence, colon 0 point. right? And we can see what that matches. It just matches any text that's exactly that. That's, you see that highlighted. And then I type square bracket 0 dash 9 square bracket, curly bracket 15 curly bracket. And so that's applying these two notational conventions that we just described. The first one is that if I put curly brackets a number, that says repeat the pattern in front of it that many times. That curly bracket says 15 of whatever patterns just before that. And the pattern that's just before that is just any digit. And we express that by saying square bracket 0-9 square bracket. So what we're developing here is a thing called the language of regular expressions. And so it'd be a particular grammatical way of describing any pattern in text. And again, if you have a question, you may want to do it audibly, because if I switch back to the BB Collaborate screen, you will see the infinity mirror. Unless I do a little trick here.
Nora was just saying that regular expressions are fun.
Oh, okay. They are. That's truer statement was never said. Okay, there's the chat. Okay, so I can see the chat now. Great. Okay. So I'm going to try to move ahead, and just give me a holler if this form of sharing is a headache. Okay. So now we want to do is we're going to try to see if we can't write a regular expression that's going to match that god-awful bit of hexadecimal there. So the way that I indicate a hex character is by saying square bracket A-F 0-9 square bracket. And so what that says is anything from A to F and anything from 0 to 9. So that first square bracket is just saying some hex digit. And then curly bracket 8 curly bracket, that recognizes those first 8 things on each line. And then I say dash, and then again the hex digits in square brackets, followed by a curly bracket 4, and that recognizes the next group of 4. So watch it again. So now we're going to recognize the second group of 4. And now I'm putting a parenthesis around that group there and saying I want 3 of those. And so what that does is that takes my pattern out, so it now matches the 3 groups of 4 hex digits, each of which are separated by a dash. So there's now I'm going to have 3 of that group. And then I'm going to finish it with 12 hex digits. And now I can match the full. And then when you see them all disappearing, that's me pressing replace with nothing. And so that's essentially taking that bit of text out of there. Now you might think to yourself, what if I wanted to do that with the timestamps? And we can see, well, the timestamps are going to be a digit, colon, a digit, colon, a digit. So that first part, right, is going to be a digit, 2 of them, followed by a colon, and then again the digit, a digit, followed by a colon, and then 2 more digits. So I could repeat in there in this kind of way. Okay, questions? Anything seem mysterious so far? Okay. So there's there's our text again, and this one looks a little bit different this time. So and this is not animated, so we can just stare at it. So let's start up and look from the left. So we've got A-F 0-9. So that says look for a hexadecimal digit. And we want 8 of those. And then we have parenthesis, and where's the other end of that parenthesis? It's all the way at the end, right? So before the plus sign. And inside of that parenthesis, we have a dash, and that's the dash that's in here. And then we have a hex digit, and then we have curly bracket 4, comma 12, and then a curly bracket. So we're expanding our notational convention now. And before we said if you wrote a number in curly brackets that said repeat the pattern that precedes it by that many times. When we have 2 numbers in there, it's going to mean repeat it at least this many times and at most that many times. So what's the difference between a curly brace and a regular bracket? Is it just for organization? No, it's a difference at the level of semantics. So the square bracket indicates the membership in a character class. So square bracket A square bracket, that says I'm only interested in the letter A. Or square bracket ABCD square bracket would mean the character class consisting of any of the first 4 letters of the alphabet. Or if I say character class square bracket A-F square bracket, that says anything from A to F. So square bracket always means a class of characters. The curly bracket in this instance here is referring to repetition. So curly bracket 4 curly bracket means the pattern we just described 4 times over. Or curly bracket 4 comma 12 means repetition, at least 4 of them, and at most 12 of them. Now you might say, what do I mean when I say at least, at most? What I'm describing is any pattern that fulfills that rule will match this regular expression. So in this case, I'm matching something that has 4 hex digits dash 4 dash 4 dash 12, but it would also match something that had 4 hex digits dash 5 hex digits dash 6 hex digits dash 12 hex digits. Right? So I could have different ones that would match it. So there's more things would match specification than we're looking at here. Now there's one more convention that is showing up here, and that's this plus sign at the top. So the plus sign is going to stand for one or more of these. So I think we'll go over here. So X plus means one or more copy, and X curly bracket M comma N means repeated at least M times and up to N times. So I'm looking at a typo here. No, I'm not. Sorry. So the pattern that we want to think about here, where the stop and think is A plus, B plus, and then C curly bracket 3 comma 5. And we want to say which of the patterns below will match this. So remember, plus means one or more, and the 3 comma 5 means at least 3 of them and at most 5 of them. So this version of screen sharing will not let me actually see those. Oh, I'm sorry. So how do you agree or disagree? At the bottom of your BB Collaborate screen, there's a hand using a blue camera, a microphone, and then there's a thing called your status. And you click that icon, and then you can agree or disagree. But if I try to see that, then it does that for me. So, okay, so we won't be counting, but so does it match A, B, or C? Answer is no. It doesn't match A, B, and C. And the reason is it fulfills the first part, A plus, which is one or more A's. The next part is one or more B's. But then for C's, we need at least 3 C's to match the pattern. We don't have that here. Now, the next one, A, B, C, 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 does that match? It matches the first part with A, and then we have a B, and then we have 3 C's. That matches because we need at least 3 and at most 5 C's. How about A, B, 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 C, C, C? That again matches because A, we've got A plus sign. That means one or more of the A's, and then one or more of the B's, and then 3 to 5 C's. A, B, 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 C, no match. All A's, here 5 A's, no B, and 5 C's. Does it match? Shaking your head no. Exactly, it doesn't match because B plus means you have to have at least one B. And then down here we have A, B, C, 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 6 C's. That doesn't match because we've gone beyond here. However, that part does match. Okay, so that's an important thing. We're going to see how to play with that part in a bit. But the whole thing doesn't match because there's 6 C's, but this first part would match. Okay, I'm going to just jump to this page where it's going to talk about all the ins and outs of regular expressions. You should spend some time reading it over. It's not hard stuff at all, but it does require some kind of slow reading, and you have to commit a couple of things to memory. If you're like me, you'll have to remember them every time you use regular expressions because my brain just doesn't hold the stuff for the long term. So I'm going to go to that page. So in JavaScript, we'll see later how we do this, but the basic gist is we're going to put a slash and then the pattern, and pattern is the stuff we've been writing so far, and then a slash, and then there are some modifiers that can go after that. These modifiers are things like, should I scan for the pattern more than once across the page? Should I care about uppercase and lowercase, and so on? There are some things we can do when we find patterns. We can find a pattern and replace it with something. We can just take a piece of text and test whether it matches a pattern, and so on. So that's stuff like that. So here's where we get the basic description. So so far we've seen the first one, square bracket ABC. That means any of those characters. Square bracket 0-9 means anything within the range. And then I can go parenthesis X vertical bar Y. That says either X or Y. So the vertical bar here is an or, and the parentheses says this within this set. Then we have this thing called meta characters, and these refer to classes of characters. So /D is a digit, so that's the same as bracket 0-9. \S, and notice it is the backslash, it's not the /. \S stands for a white space character. \B means the beginning of a word. Now \B is kind of funny because it doesn't really take up any space. It just says that only counts if it's at the beginning of a word. And then we can have fancy characters. These are the 3 quantifiers that I always have a hard time remembering. An N with a plus means one or more. A pattern with an asterisk means zero or more of that. So if a character is optional or a pattern is optional, and if it occurs, it can be any number, then I put an asterisk. And if I want 0 or 1, so it can be there or not be there, but it's only one, it's not repeated, then I use a question mark. Questions on notation? So we're going to see this in action in some code in a bit, but this much right here is you kind of have to memorize it. You have to sort of look at these and revisit them because they're not obvious. They are simple, but if you don't know how to use these tools right here, everything gets very hard. The W3 Schools site is great because you can go and try things, right? So I can jump over here and it gives me some examples of this in code, and then I can play with the code here and I can try it out here. So I encourage you to do that. Questions? No? Yes? Makes sense. That's good. Okay. Let's go back here. Oops. Are we still seeing me? Okay. Great. Okay. So so let's jump right into the deep end and play with some regex that's going to validate some web input for postal codes in the U.S. So the U.S. zip code is 9 digits, or excuse me, 5 digits, with an optional 4 after that. So my zip code might be 19013, but I can also add 4 after that, so it would be 19013-1012 or something to that effect. So let's look at the code as we've got it here, and we understand why it works. So remember, the \B says the beginning of a word, right? So this is going to make it so that I'm not recognizing zip codes within other words or within longer numbers that might be data or something like that. It ends with the same thing. So I've got I've got a /B at the end. The whole thing is between forward slashes. So in JavaScript, we're saying we're going to create a variable called RE, standing for regular expression, and it's going to equal, and then it's just text that starts with a downward slash, ends with a slash. This regular expression is going to find something that is a standalone word, and the 0-9 says start with a digit, and how many of them? 5. And then I have a parenthesis starting here and going to here. So the parenthesis contains a bit of pattern. And the thing that it includes is a dash followed by a digit, bracket 0-9 bracket, and 4 of them. So are you persuaded that this regular expression is the regular expression for a 9-digit zip code? 5 digits dash 4 digits. But then notice the question mark at the end. So this question mark at the end is after the parenthesized section. And so what it says is this regular expression consists of 5 digits for sure, and then either no 4 digits after that, or 1 copy of 4 digits after that. So let's just test to see if it works. So there's a valid zip code. Now let's see if I put 6 digits in instead. So, nope, it's not a valid one. What if I said A, not a valid one. Let's put in a Canadian one. Perfectly valid up here, but that's not being recognized. And if you look at the rest of the code, the way that it's doing it is it says if regular expression dot test, and this is the regular expression. So if I say regular expression dot test of the input, right? So the input, which was input equals get the thing. So I basically am taking this input and testing it right here against the regular expression. So re.test with some input is going to be true if the pattern matches. It'll be false if the pattern doesn't match. So if the pattern matches, I'll say thank you over here. And if it doesn't match, I'll say it's not a valid input. Okay, so here's our assignment to make it work for Canadian postal codes. And don't look ahead to the next slide because you can tell that's where our solution is. So what's the rule for Canadian postal codes?
I guess it's a letter followed by. I mean, sorry. It has to consist of 6 characters.
Right.
The first 3 will be a letter, number, letter, and then the second 3 would be a number, letter, number.
Okay. So on my presentation slide, I'm just going to write a little comment that says, so it's letter, number, letter, number, letter, number. So what's the regular expression for a letter?
I guess it would be the square bracket 0 to. Oh, sorry, for like square bracket A to Z.
Uh-huh. And if we want both upper and lower case, we do it like this. We go A dash Z, and then little a dash Z. And so that would say that part right there is now going to be any letter. And then we have a number, and we can just copy the letter part again. And then we just reverse the pieces. Okay, so if you're still looking at mine, let's try putting in a postal code, and it works. But now I'm going to put in a space, and with a space, it doesn't work. So remember that the code for a space is a \s. And so I have my letter, my number, my letter. So I'm going to put a \s in here. And now I'm going to try that again. M for X space 1A6. And it says that's valid. But now when I take this out, it's not valid. So does anybody remember what we do? And again, you'll have to be acoustic because I can't see the chat.
Question mark?
Put a question mark in, exactly. So I just put a question mark in right here. And now I'll go M for X1A6. And that's okay. And then I'll put a space in, and that's okay as well. What if I said, I want to just let, I think that should work too, right? So for that, I could put in an asterisk. And now I'm going to go M for X space 1A6. and that should work. So this is a moderately hairy regular expression, right? There's a certain amount of, if you look at that late at night, your eyes might glaze over, right? But we can take it apart if we just remember those different pieces of the rules, right? This just telling us about a class of characters. This is telling us about a class of characters. This is telling us about that. This part is a pattern that has some flexibility to it, 0 or more spaces, and then 3 characters after that. And the B's just say it has to be in a word. And we can test that, say, if I said TTT, so I still have the valid postal code here, but it's not in a separate word. So it's going to say that's not valid. If I put a space in there, I actually have no idea what I think it won't. I think I won't like this. Oh, it does like it because it did match that because it saw this space here. So it said, yeah, I found a match in that string. So in general, on our blue slides, we have the solution for these things. So you can use this code right here as the sort of standard version of the code for web validation, um, uh, for passwords, for bits of addresses, for email addresses, and so on. The HTML for this is just right here. Right? It's just postal code and then an input box and then a button that will, when we click it, it causes this JavaScript program to run. Okay. This is a foreshadowing of one of the problems we have for the problem set. And what we want to do for this is to build an email validator. And so we just wanted to kind of go over the code and the HTML here right now, so we just got familiar with it. So the HTML is in this page that we see on the right. It's just got some text up here. That's all this stuff up here with the instructions. And then at the bottom, we have this table, and the table contains our test data. And so we're trying to write a regex for valid email addresses. We want to implement the rules at the top of the page. And if we test something, it should have it so that all the things on the right-hand side fail the test, and all the things on the right-hand side should pass the test. And if I try that now, if I just click submit to run the test, right, we can see that everything comes up fail. So I get X in front of everything. And if we go back to the JavaScript, we can see where that happens. So at the bottom here, it says there's a variable called the output for the yes tests, and there's a variable called the output for the no tests. And this is a very weird little bit of JavaScript. It doesn't, our working of this problem doesn't depend on us knowing this syntax. But the syntax is, this part is a condition, and then the question mark, and this is the value if it's true, and this is the value if that condition is false. So this syntax here, condition, question mark, value, colon, value, is just the JavaScript implementation of the simplest diamond decision structure in a flowchart. So remember, the diamond in the flowchart is if the condition, then we go to the left if it's true, We go to the right if it's false. And so the simplest version of that is just if the condition is true, then the value is this. If the condition is false, then the value is that. So that's just a shorthand that JavaScript gives us here. So what we're doing is the output is going to be a list tag, and the list tag in JavaScript in HTML is what's producing the bulleted list. And so each of the items in the bulleted list is going to start with a li tag and end with a /li tag. And then the stuff in between is going to be either an X or a check mark and a space, and then the testing, the email address that it was testing. So that's all that this is doing right here. The test itself is coming the same way that it's all before. Regular expression dot test, and then the test data. The test up top here is just a JavaScript array. So it's square bracket, a string, another string, another string, and so I've got 1, 2, 3, 4, 5 email addresses in the yes testing case, and I've got 6 of them in the no testing case. The regular expression is right here. So right now it's set up to say a word boundary /b and a word boundary /b over here. And then one or more A's followed by the @ symbol, then one or more B's followed by .com. So if I put in aaa@bbb.com, this part of the output tells me that that particular test case was valid. And then all the other ones at this point are not valid. They're not matching it. So that's using this as the test. Now suppose I said, I'm going to put Z in there. So that says that the regular expression now is a Z followed by any number of A's, or by one or more A's, the @ symbol, and then one or more B's. So if I do ZAAA at b.com, then that works. If I leave the Z off, it doesn't work. Now, you might have asked yourself, why is there a backslash in front of the @ symbol? Anybody ask themselves that? The thing we have to do is when we want a symbol which means something in the regex language, when we want to use that in a pattern, we have to have some way of telling regex, don't treat that as what it means to you, treat that as a character. And we call that operation escaping something. And so if I wanted to use a square bracket as a part of a pattern, then I would have to say \square bracket. I'm escaping it to say regex. I know that you think square bracket means something normally, but in this case, I'm using it in a special way. And technically, I should have a backslash here as well. I should have to escape the period because the period means something in regex language. The last little bar up here is this is not actually a restriction, a real world restriction on domain names, but we're saying the upper level domains we're going to consider are just edu, com, org, and ng. Okay, so just to give a little head start, right now we're saying .com only. So if you remember, we learned earlier that you could use the vertical bar to express or. in regex. So if I put a parentheses around calm, that's just saying treat the stuff in there as a unit. And then if I put a vertical bar in here and added ng, so now I could write ZAAA at bbb.ng, and that should be valid. Whereas if I take that out and try that, then that's not valid. So in the quiz part of this, I have it set up. It just says, look, watch one of these guest lectures. So the first one is really pretty short, and the speaker here slips into a more formal part of computer science that regular expressions are related to, namely finite automata or finite state machines. It turns out that they're mathematically equivalent to the way we're describing regular expressions. And it's a neat way, if you ever are interested in computational linguistics, of defining languages. So regular expressions is a way of defining a formal language. So that lecture has a bit of that in it, and you can see that right on the cover there. The second one is a little bit longer. No, it's a lot longer. It's from an O'Reilly meeting, but it's oriented specifically toward JavaScript and kind of goes through everything. So you'll learn a lot from that if you watch that one. And then lastly is our friend from CodeTrain, who I think we've seen him once or twice before, and we'll see him again when we do APIs. He's a great explainer. He's a bit manic, but and he often uses a JavaScript library called P5. So if he mentions that, that's what he's talking about. Anyway, so watch one or more of those videos, and then read something about regular expression to get a sense of how these are not just a little detail that we use for writing validators on widgets. They point at the general problem of pattern recognition in a really important way. So just read through these things, get a little sense of the connection. And then lastly, there are some fantastic tools out there. So this is a tester. So you put text in here, and then you try out the regex up here. And what it does is each little piece of it, the hover text will tell you what that piece of regex does. So you can sort of learn right by doing that. So play with one of those. And then the last thing I commend to your attention, and I think we're just a bit over time here, so I apologize. The last thing is you should look up the regex golf is a thing. So regex golf is it's like golf where you're trying to get the ball in the hole with the fewest number of strokes. And so what you want to do here is you want to write a regex which will match all of the words on the left and not match the words on the right. And you want to do it in the shortest regex possible. So I might start out and say, okay, so the letter O, two of those. And then I say, no, actually, it's not that. It's actually the word foot. And then before foot, I could have A or cat or And I could play with it like that, and I say, yeah, but that's not going to match down here because these are. So maybe it really is two O's. So it's going to be O2 followed by T or DY, and so on and so forth. So you basically just try to figure out what regex would match these guys, but not match these guys. And then as you go along, you do another one, and they get harder and harder and harder. So that's everything. I'm going to jump back to the real BB Collaborate window over here. Shall we say goodbye? Audibly?
Bye-bye.
Bye, everyone.
Bye.
Have a good day.
Bye. Have a good weekends.
Thank you.
Ciao.